In this question, you're being asked to write a complete arrow pushing mechanism leading to the expected major product of each of the following reactions. So again, we are in the lecture 14, that's the SN2 lecture. We didn't start talking about a bunch of other competing reactions yet, so mostly these are just going to be SN2 reactions. And so what I'm saying that for is because that means you pretty much know that right now, but in the future, you're going to have to evaluate everything to figure out, is this going to be SN2 or one of the other competing reactions? So just be aware of that. All right, so I'm just going to kind of go through the steps here. I already looked at the previous example, number 2, I believe, and we pretty much evaluated what was the substrate, what was the nucleophile, so we already kind of did that here. But again, this is the substrate. The chlorine is the leaving group. The carbon attached to the chlorine, that's the electrophilic carbon that's going to get attacked by the nucleophile. Here in this species, this is the nucleophile, specifically nucleophilic at this oxygen. That is what's going to donate the electron density and act as the nucleophile that will attack the electrophile. So we pretty much just need to predict what the major product is going to be and draw a mechanism, which means explain how the electrons moved, how bonds formed, and how bonds broke, and show that movement of electrons using arrows here. So I'm going to redraw this, this substrate here. All right, and I'm just going to show all the bonds here. And then there's a bond to this chlorine. Now keep in mind that that chlorine has a partial negative, which means the carbon has a partial positive. Because the chlorine's more electronegative, it's pulling electron density away from that carbon. Now that sodium methoxide, I don't really need to draw this sodium cation in there. It's not really important for this. So I'm just going to draw that oxygen, but I am going to put the electrons here. I'm going to show those, and I'm going to show that there's a negative charge. I'll even put the electrons here on chlorine just to kind of show that they're there. All right, so what's going to happen here? Well, we know the carbon of the methyl chloride has a partial positive charge. We know that the oxygen has a negative charge. It has the electrons that are going to be donated. So what's going to happen is those electrons are going to attack this carbon. Now that carbon already has 4 bonds to it, so something has to leave. And the best thing to leave is the chlorine, because the chlorine will leave with negative charge and it'll handle that negative charge well. A hydrogen's not going to leave because a hydrogen would leave with negative charge and it is not going to handle that negative charge well, but the chlorine will. So we're going to show the electrons between the carbon and the chlorine. They're going to end up on the chlorine. So now what we have is we have a new bond between the carbon and the oxygen, and that methyl group that was attached to the oxygen, it's still there. It came along for the ride with that oxygen, and the thing that left here was the chlorine, and that chlorine now has those electrons. So that would be a complete arrow pushing mechanism for this, and this would be the expected major product here in ether.